Addisons disease by Lotte. Addisons disease is an adrenal insufficiency. There are two types, primary and secondary. Primary is caused by the destruction of the adrenal gland, causing corticosteroid insufficiency. Examples of corticosteroids are aldosterone and cortisol. The adrenal glands are pyramid-shaped endocrine glands which are perched atop the kidneys. They produce hormones which help us deal with stress. The bulk and outermost layer is the adrenal cortex. The zona glomerulosa is the outer layer of the cortex and produces aldosterone. The middle layer is the zona fasciculate. This is responsible for cortisol production. The inner layer is the zona reticularis. Mineral corticosteroids. Aldosterone is an example. Aldosterone is stimulated by renin-angiotensin-aldosterone mechanisms, elevated blood potassium levels, and ACTH. Aldosterone targets the kidneys and increases blood levels of sodium and decreases blood levels of potassium. This is homeostasis. Blood volume and blood pressure rise due to the retention of sodium in the blood. Aldosterone is a steroid hormone and binds to plasma proteins for transport in the circulatory system. Aldosterone binds mostly to albumin. Aldosterone production. A decrease in renal blood flow allows for renin to be released. This converts angiotensinogen to angiotensin 1. Angiotensin 1, with the help of ACE, converts to angiotensin 2. This stimulates the adrenal cortex, where aldosterone is released. This increases blood flow and blood pressure, causing negative feedback. Cortisol is an example of a glucocorticoid. Cortisol is stimulated by ACTH. It targets body cells to promote gluconeogenesis and hyperglycemia. It is also responsible for mobilizing fats for energy metabolism, stimulates protein catabolism, assists the body to resist stressors, and depresses inflammatory and immune responses. Cortisol, like aldosterone, is a steroid hormone. Cortisol binds largely to corticosteroid binding globulin and globulin. The negative feedback. When cortisol levels drop, the pituitary gland monitors that and releases ACTH. This stimulates the adrenal cortex, where cortisol is released, therefore increasing cortisol levels in the blood. This causes negative feedback. Cortisol and aldosterone are steroid hormones, meaning they are hydrophobic. This allows them to easily pass through the cell membrane. Sue is a Caucasian female of 27 years old. She has an autoimmune disease which she inherited from her parents. Symptoms she's experiencing is salt cravings due to the lack of aldosterone, muscle weakness due to the lack of glucocorticoids, muscle or weight loss and anorexia, also from lacking glucocorticoids, hyperpigmentation, decreased blood pressure as a lack of aldosterone, and lowered blood sugar as a result of lacking glucocorticoids. Adrenal malfunction. Autoimmune disease is the primary cause. The immune system views the adrenal gland as foreign and something to attack. By the time Addisons usually becomes apparent, about 90% of the gland will already be destroyed. Tuberculosis, although rare in Canada, is still often seen as a contributor to Addisons in non-industrialized countries. Tuberculosis, although mostly found in the lungs, can be found in the adrenal gland. Other reasons can be the spread of cancer or infection in the adrenal gland or internal bleeding. Scenario. Possible treatments that Sue can take is taking hormone replacements to replace the hormones the adrenal gland cannot make on its own. This can look like oral or injection corticosteroids. Androgen replacement is available for certain women with decreased libido. High salt diet for heavy exercise, hot temperatures, and diarrhea before surgery and when stress is recommended. In summary, homeostasis is effective as there becomes low sodium, high potassium, due to aldosterone not being able to regulate it. Proteins. Cell identification proteins present as foreign. Aldosterone and cortisol require proteins for transport. These proteins for transport are albumin, corticosteroid binding globulin, and globulin. Cell membrane. Steroid hormones pass through the cell membrane. Cell membrane is the site of self-identification proteins.